Hi, my name is David Pena. I will talk to you about nuclear power, the energy source that we need. Um, this is a reliable energy source. It is the second largest energy source uh, that we actually use, second just to hydropower. It produces 10% of the electricity that our planet uses right now, but it has an stigma, and it it doesn't deserve it. We should appreciate. For that, the purpose of this presentation is to state why it's a clean and sustainable energy source. And even though it has its challenges, it has its solutions, and it should play a vital role in the clean energy transition, as you can see in this index. Well, what is nuclear energy? There are two types of nuclear energy, fission and fusion. Fusion hasn't been developed yet to a point where it's efficient, so in this presentation we will only talk about fission processes. Fission is where we irradiate a sample, usually it's uranium-235, with a neutron. When the neutron collides with the uranium, we produce two fragments that have similar mass, and it's similar to half of the original mass. And also we can produce 2 or 3 neutrons, but the sum of these masses is not the same that the original. The missing mass in reality is energy. It has transformed to energy. Okay, now the 3 reasons why nuclear energy is clean and sustainable. First, it has a zero emission clean energy source. It's theoretical, so in reality we produce a little bit of carbon dioxide, but it's much less than the other main industrial sources, such as fossil fuels. Also, the land footprint is really small. When we compare how much solar panels we need to produce what a typical power plant can produce, we need around 3 million solar panels just to produce what one single nuclear power plant can produce. And that's not even considering something called capacity factor that I will show you later, that demonstrates why nuclear power should be our main option for a clean energy source. And the third reason is that it has a high energy density at minimal waste. What do we mean with high energy density? We mean that with just a single uranium pellet we can produce as much energy as 17,000 cubic feet of natural gas, 120 gallons of oil, or a ton of coal. And of course, we cannot compare the waste that is produced by a ton of coal with just a single pellet of uranium. But even though the waste is minimal, we have a problem. This is a radioactive waste. There could be accidents, such as the accident everybody knows about that happened at Chernobyl, and the mining. But also there are solutions that we have contemplated for these problems. We cannot get rid of radioactive waste, but we can contain it and avoid air, land, and water pollution. Also, for accidents, we can work on new designs, next generation power plants, and nuclear power is the most regulated energy source. And for mining, we can improve our techniques of mining. We can reduce the exposure of miners, and we can reduce the exposure of miners. Also, to conclude, I want to talk to you about the role in the clean energy transition, where we can see that nuclear energy has a lower output of carbon, lower than even biopower sources, and it's comparable to the photovoltaics, but it has a significant advantage over the renewable sources. The capacity factor. The capacity factor is a way to measure that we can use this source all the time. So if we have a reliable source, such as nuclear, that is much more reliable than hydropower, coal, wind, and solar, we can have the electricity available all the time. And finally, I want to talk to you about what we expect in the next generation nuclear power plants. We don't want to just produce electricity. We can produce hydrogen. That's the idea. And with that, we can also help the development of other clean energy sources, such as hydrogen cells, as my classmates have already told. Thank you for your attention.